Welcome back to Algebra 1 Honors, your second lesson here about grouping symbols. Now, I might retitle this lesson, Parentheses Are Powerful, okay? And indeed, we're going to be doing some exercises using pipe cleaners to move parentheses around. You have essentially three kinds of grouping symbols that your book uses. Later on, you may learn an additional set that's not up here. Right now, you're going to be using parentheses, that's the curved ones, brackets, that's the square ones, and then they also talk about, your book talks about the fraction bar as being a grouping symbol. I never thought of it that way, but I'll explain to you why your book includes that as a grouping symbol, because indeed it does force you to group some things together. Now, if you look here, without any grouping symbols here, following our please, excuse, my dear, Aunt Sally rule, my order of operations rule, I would come across, first look parentheses, there aren't any. No exponents, no little floating numbers up there. Multiplies and divides, oh, there is a divide right here. So if I don't have any grouping symbols there, first thing I'm going to do is this operation right here, and I'm going to have 10 plus 25 divided by 5, or 5, and then I'm done with all the multiplying and dividing. Now I do the last addition, and I get 15. Okay? I can change that, however, and get a different value if I include grouping symbols. Okay? So if I put something like this, if I grouped these two together, these first two numbers together, then I have parentheses. So please excuse my dear Aunt Sally, I've used the parenthesis grouping symbol. And that means that I have to do this first. So I add 10 and 25, and I get 35. That's the value of the numerical expression that's in that parentheses. Then divided by 5, do that operation, and I get 7. Okay, so I get a different number if I use grouping symbols than if I do it without grouping symbols. Okay? Now, over here is why a fraction bar is a grouping symbol. Okay? And I want you to remember this, because when we get to variable expressions here, this is a classic situation where students want to do some canceling and you're not allowed to. Okay? If you look at this, we all know that 3 plus 10 is 13, and 6 minus 2 is 4. So another name, a correct name or a for that value there, is 13/4, which is 3 1/4. Okay? You cannot do the division this way, okay, or this way. Because if we did that, let's say we made that mistake and we cancel, we have 3 into 3 once, 3 into 6 twice. Hey, this is a big no-no here that I'm explaining. 2 into 10 would be 5, 2 into 2 would be 1, and look what we'd get. We'd get 6 over 1, and these are not equal, not the same. Okay? So the grouping symbol of a fraction bar means that, okay, you cannot do this. You have got to get a value for the top first, simplify up there, then get a value for the bottom, the denominator, and then do the divide. Okay? When we get to variable expressions, we'll have things like this. And inevitably, okay, mark my words, we'll have somebody that wants to cancel the x's, cancel the y's, and say, okay, that's going to be 5. Okay? For some reason, that's just a very instinctive thing to want to do. You have to go back and remember, Can't do that. We don't know what x and y values are, but we'd have to find them out in order to calculate this first, and then this. All right? Now, all right, let's look at another use for grouping symbols coupled with two other properties that we're going to learn about. If you had the following challenge problem. Okay? Now, if you tried doing this in your calculator, it wouldn't work terribly well. Okay? Calculators don't do fractions very well. What we can do here, because we have all multiplies, there's nothing being done in a macro sense here except multiplying and divides if you look at the fraction bar. We can use two of our properties called the commutative property. Commutative property means that if we have a multiply or an add, we can take the two operators, okay, the two factors or the two addends, and we can switch them. They can commute. Okay, so we can change this to 793 times okay, that's the commutative property. That allows us to make this switch. They flip-flop. Now you cannot do that with subtraction or division because 7 minus 4 is not the same thing as 4 minus 7. This is a positive 3. This you're going to be in the whole 3, a negative 3. Okay, so the commutative property only works for addition and multiplication. Okay, but that allows us to do this. And then because it's all multiplies here, I can now use my associative property to do the following. The associative property is like making a new association, a new neighborhood. Okay, so here I have this neighborhood. I'm going to change it, and I'm going to associate or group together these two numbers. And again, I can do that with multiplication or addition. Okay? Now the problem becomes very simple. Right? So using my grouping symbols and my two properties, now right here I can see that this goes into this once, this goes into this once, and that's essentially 1 times 793. My answer is 793. Okay? Now, one last example of where you might want to use grouping symbols. Okay? Let's play the guess my number game. Okay? I'm thinking of a number, some number. You don't know what it is, okay? And I tell you that I take 40 away from that number, okay? Take 40 away from that number. And then I double the result, okay? I take 40 away, I double the result, and I get 120, okay? Now, I have to use parentheses if I want to keep track and accurately figure out what that number is. Because what I said was I'm thinking of a number, all right? I take 40 away from that number, okay? And then I double what I have left. If I just put the 2 here, okay, and I put I told you I got 120. If I did it this way, okay, then the answer you're going to get, my number, by the way, was 100. Okay? My number was 100. But if I write it this way, without using my grouping symbols, I'm going to get an incorrect answer. Because if I solve this equation and figure out what the number was, I'm going to add 40 to each side. Right? I get 2 times my number is equal to 160. And my number here, 2 times what is 160? Well, it turns out to be 80. That's not what my number was. And the reason that I got this wrong is because what I said was the first step is to take your number and subtract 40. That gives you an answer. So this is a quantity, right? It's called the quantity. N minus 40. My number minus 40. And then I said, take what you have left and double it. So you're doubling what you have left here. Now let's see if we get a correct answer this way. Now you haven't learned to distribute yet necessarily, so we're going to do this with what my algebra teacher used to call the cover-up method. Okay, and it's a real easy way to solve things. We're going to take a paper and we're going to cover up the variable here. Okay, and we're going to say, okay, 2 times what gives me 120? Well, 2 times 50 is too small. 2 times 60. So what's behind the paper has to be 60. All right, because 2 times 60 would be 120. Well, now let's see what's behind the paper. What's behind the paper is this. So let's cover up the variable again. What minus 40 gives me 60? Stop and think for a minute. 80 is not quite big enough. 100, right? 100, put 100 right here. 100 minus our 40 gives me 60. And that was the number I was thinking of over here. Okay? But grouping symbols were very important there. So if you were taking notes and you were trying to write down the various steps that I told you I did to my number, my magic number, you need to put parentheses around your number minus 40. Because it's the result of the quantity, the result of that operation that got doubled, the whole thing. Okay? Not just the number and then take away the 40. Okay? It's another reason why parentheses or grouping symbols are very important. And that's pretty much what there is to lesson 2. It's very simple.